Welcome to Homework Lib.
In a survey of 320 families that had 5 children each, the numbers of boys and the numbers of girls were tallied. And in this table are shown the results in which we have the numbers of families that have each combination of boys and girls that's possible. So we could have five boys and 0 girls, or we could have 4 boys and 1 girl, 3 boys and 2 girls, etc. And we're asked to calculate the test statistic to test the hypothesis that male and female births are equally probable. So the null hypothesis is that the proportion is 1/2. To test if a 50% distribution is a good fit, we can calculate a chi-squared test statistic according to this formula. So E sub I is the number of expected outcomes for each category. So the different combinations or different proportions of boys and girls are different categories. So each column is a category. So in each of these categories, out of a total of 320 families, if the probability really is 50-50 for boys and girls, we would expect probabilistically a certain number of families to have 5 boys and 0 girls, and a certain number of families to have 4 boys and 1 girl, etc. So we can do this by testing just whether the number of boys is what we expect it to be, or alternatively, if the number of girls is what we expect it to be. So let's just use boys. Let's just use girls. So we can go from 0 to 5. So if the random variable is the number of girls, and the probability of a girl is 50%, then what number of families would we expect to have 0 girls, 1 girl, 2 girls, etc.? In this scenario, the number of girls is a binomial random variable. So let's calculate the expected outcomes for each category. So we have 0 girls, or 1 girl, or 2, 3, 4, 5. Let's first calculate the probabilities of having 0 girls for a family of 5 children. So equals binomial distribution function, select that function. I'm going to hit the up button to select the cell in row 2. In this case, that's 0. Number of trials is 5. Each family has 5 children. Probability is assumed to be 0.5. We enter false for the cumulative argument and hit enter. So this is the probability for a family of 5 having 0 girls. And then we can drag this formula across for all the different possible values of different numbers of girls in a family of 5. Now, to calculate E, remember E is the expected number of families in each category, if there are 320 families. All we have to do is multiply these probabilities times 320. So I'm going to select the probability, multiply by 320, hit enter. And so this row will have our E sub i's. In this situation, the observed number is what we see in the last row. This is the actual observed number of families with these numbers of girls in their family. So let's enter that as a row in Excel. So they're 14, 56, 110, 88, 40, 12. So these are the observed values. And now we want to calculate this summation to get our chi-squared test statistic. So let's start by doing this for each category. So equals, so it's O minus E. So O is in row 5, subtract E, which is row 4. Then this is squared, and then it's divided by the expected number. So in the divisor, we have the value that's in row 4. So we hit enter. Okay, I just noticed something. I made an error in here. I put the probability of 0.25. It should actually be 0.5. So just fix this for all of row 3. So now we have the new expected values in row 4. Same observed values in row 5. So now let's continue calculating the difference squared divided by the expected value. So we just drag this formula across all the categories. So now the last thing is to sum them all up. So I'm going to use the sum function, enter all of these values as the arguments, hit enter, and we get 7.16. And so this comes out to 7.16, and that is our chi-squared test statistic for the hypothesis test of the proportions of boys and girls being equal, or the probabilities of having boys and girls being equal.